My name is Ron Dagdag, and today I will be talking about building intelligent apps with ML.NET and Windows machine learning. If you have questions, feel free to put them in the chat. I will also post the uh, the copy of the slides and also the presentation for today. I have it on the chat. I will be monitoring the chat for any questions. Feel free to unmute if you have any questions. Question: who among here are Windows developer and who among here have used the Windows key or ever felt like the Windows key? Uh, while we're waiting for others to chime in, feel free to write down any use of the Windows key that you're using right now. What do you use it for? And feel free to put them on the chat. Anything that you use the Windows key for, keys that you want to share with others that others may not know because it's not commonly used. And the reason why I talk about have you ever felt like a Windows key? If you're a Windows developer these days and you know a lot of the desktop applications and how to create desktop applications and all that, with all the different technologies that are coming out, felt like you felt like the Windows key, like it's there, but it's not being used as much because of the world of move on to the cloud, the world of move on not just desktop, but maybe in browsers of all these different things on the phone and all, different applications. Oh, one tip I wanted to showcase is that I started using the Windows key, and there's this Windows Shift S key, and I use Windows a lot, and I've used this to capture the screen. So every time I do a presentation, I started using these because let's say I want to showcase something, I want to capture something on the screen. It's just a quickest way to capture something on the screen, uh, and do a snippet in Sketch Tool. And the Windows key, they have all these odd combination. It feels like I'm doing the piano because Windows Control Shift Alt, and then Outlook is I don't know. One of these days, try it out and see. It feels like magic, and still not used to this. But what I'm saying is that there's some little complications and little things in there that the Windows key can actually support now. Anyway, today I want to talk about Windows. What is machine learning, and then we'll talk about what is Windows machine learning, and then what is Open Neural Network Exchange, Onyx Runtime, Community Toolkit, ML.NET, ML.NET Model Builder, and we'll go through each one of these and try to define and kind of give you that the idea about what is Windows AI. So let's go back. A lot of us are developers here, and I've been a developer. I've been developing since 2000. It's been 20 plus years, 22 years. Programming, typically you need an algorithm and an input, right? In this case, we're building a calculator. So you need to be able to, you need two things. And then of course, if you build a program or a calculator, and it would spit out the answers for you. In machine learning world, in machine learning, it's like the other way around, right? You have your input, but you would need lots and lots of examples to showcase a lot of examples or answers. And what the goal is for the machine to learn and spit out an algorithm for you. So as a machine learning primer, programming on the right side where you have your input, algorithm, and spits out answers. In the machine learning world, we have answers, input, and then algorithm. We call that the input and answers, we call that in machine learning, we call that training data. And you need a training framework or machine learning trainer framework to build a model for you. And that model, you would replace it or you would use it into your application. And then we call that in machine learning inferencing. And then you need a runtime in order to get in order to use that model and give out answers for you. Today we will discuss a little bit of the ML.NET is also a training framework. We'll discuss a little bit on this side. And then, of course, on the right side, where we do the inferencing, where you incorporate, machine learning into your application. All right, let's move forward. Okay, why do you want AI on the edge? We've heard about this AI, we've heard about this machine learning. Inferencing is, running the application into your application. Edge for me is more of how close it is to the users. Why do you want your AI or machine learning running at the edge? Edge meaning it could be the phone, it could be the desktop machine, right? Why do you want to run machine learning on the desktop rather than in the cloud? One thing is because of low latency. If you're processing some data in terms of camera data or sound or something that you want really, quick response, it makes sense to run it on your desktop application or include it in AI into your application. Scalability, of course, instead of sending some data to the cloud or sending some data to the cloud and then do some AI processing there and receive some data back, it costs less if you have a performant desktop, if you have a performant mobile device. It's good. That's good enough that it can actually run the machine learning model and use it. Your application would scale. It's cost cheaper, and also flexibility. If you are on a ship or a plane, application still works. The AI side of it still works, and it can do some prediction. So those are the three main reasons why you would want to run AI into your application or integrated to your application. So what is this Windows AI platform? It comprises with three, I would say three levels. You have this WinML API that runs on top of Onyx Runtime. WinML is a practical way, which is a model-based API to do inferencing on Windows. So think about this as more of the inferencing side, incorporating model inferencing into your application. And of course, it runs on top of DirectML API, so which is a real-time, high-control machine learning operator. It's actually using DirectX in the background. And of course, it's using this compute driver model, where it can use GPU, VPU, or XPU. We don't know yet which processing unit we would have for that. But the compute driver model allows us to be able to say, hey, we're not tied into NVIDIA because we are only using NVIDIA GPU. It can also use some AMD GPU or all the other GPUs. And it's an abstraction layer for those graphics and compute silicon. What is Windows machine learning? Oh, am I actually presenting the slides? Oh, the slides are actually in the, it's a PDF on the link to on my GitHub page. So if you're interested in getting that. So we talk about Windows machine learning. What is it? It makes it easier for Windows developers to be able to do abstract model, to abstract the model specific code away. Like I said, it has broad hardware support, it had hardware optimization, and a good way for implement machine learning in Windows application, to have in the Windows machine learning into Windows application. So the key here is in performance. It's low latency and real-time results. At the same time, increase flexibility and reduce operational cost, and specifically for Windows devices. So every time I think about Windows, like I said, I've been programming a lot of I started working on Windows Forms back in the day, and I wanted to showcase that you can actually use Windows machine learning in Windows Forms. Remember those Windows Forms? So I'm going to try to run this application right here on my Visual Studio. Just to kind of showcase that, hey, I have this small Windows Forms application. There is a way for me to load this one is called an Onyx model. So this is the AI model that I'm loading into my application. And now, because of that, I can pass in to these input, right, data, and I can click predict. And based from that model, it would predict that based from this input, this is supposed to be the output. So what I wanted to showcase here is there's a way you can use machine learning, not just on the newest and latest and greatest. You can actually incorporate into existing WinForms application any machine learning. And just wanted to show you what the NuGet packages that is involved in doing this and what is installed on this one is you would use Microsoft.ml.Onyx Runtime in order to accomplish this, and everything else is about the same. So that's the key, to be able to use that, anything that's Microsoft.ml, which is part of ml.net. Okay, so that's just a quick demo of how you would use, or how you would incorporate machine learning into your Windows application, Windows AI. Now let's talk about intelligent API. Intelligent API makes it is on GitHub under Community Toolkit. It's just, if you just want to experiment and try out what is this machine learning, and you don't have all these machine learning expertise, and it's reusing this existing ML models, and I want to add this other NuGet package. There's few steps involved in order to do this, and it's using WinML on top of it. So first step, you go to the NuGet package source, identify, hey, this where you get this NuGet packages, and then there's this NuGet packages that are available there. And today we'll be talking about this image classification. And so if I just want to add image classification into my application, I can use this. And you would reference this library, community.labs.intelligent.image classification, and you call one command to do it, right? So in this case, squeezenet image classifier.classify image, and then send an image, and then it would return three top items on that list, and it would give you the result. Okay, let's try to demo this and kind of showcase this and what it would look like. Okay, so first thing you would do on this, let's say this is a UWP application that I have. I go to the NuGet packages. What I did was to add this NuGet package, specify the name, specify the source, and click update. And then I went to select that as part of my package source instead of NuGet.org, which is the usual. You would go to this, whatever you name, and then go browse, and you will see that there is this image classification. Okay, and this image classification, you would be able to add that to your package. And once you add that to your package, you can use, let's see there, using this Community Toolkit Lab image classification. And if I just want to run it, so in this case, I pick an image. After I pick an image, I call this classify image, selected that file, and it would return the result. And I wanted to showcase what that result looked like. Let me see if I can run this. Okay. So it says pick an image, pick this image, and this is the result based from that processing that model. It's using SqueezeNet, which is a free model that is available out there that is converted and it's already ready for you to use. And then you get the result that says here, yeah, that is a seashore or coast, sea coast, those kind of things, with a confidence of 96%, that kind of thing. Cool. Any questions so far?
Is your repo private? Because I can't seem to.
Okay, I will share it because I just added it to GitHub like maybe an hour ago. So I will share it after this call. But thanks for pointing that out. Okay. All right. So what's next? Okay, let's moving forward. So what is this? So typically, when you create a model, right? A lot of developers that are doing this, they would do it in PyTorch, and they would run it locally on their machine. And of course, if you're a JavaScript developer, there's a lot of frameworks about, all these, they come up with all these different web frameworks or however front end framework and all that. The same way as in the AI world, there's PyTorch, there's TensorFlow. Of course, a lot of people uses PyTorch these days, but there's scikit-learn, those kind of things, Keras. You'll hear about all these. And then, of course, when you want to deploy it now, it's not just desktop anymore. Sometimes you have to do it in the cloud. Sometimes you have to do it on the phone, all these different places. And of course, it could be CPU, GPU, all these processing unit. And that's what Onyx does. It's the bridge from, the training side. You convert it to this Onyx format. And then now you can integrate it into your application. Think about it's kind of like PDF, right? When you convert a Word document to PDF, now you can have more viewers, PDF viewers that can run. You can run on the web, the phone, and those kind of things. It does not need a special install because most likely, there's a lot of viewers out there that can read PDF. So the same way as Onyx Model. So when should you use Onyx? If you have something that is trained on Python, you have a data scientist or a computer vision developer, they're really good at Python, and now you want to integrate it to your existing C# or JavaScript application, there's that bridge for you. And if you need something that's high, that you have high inference latency for production use, you want it really fast, it makes sense to convert it to Onyx on an IoT device or something that is does not have, maybe it's an ARM processor or a different hardware or a different OS. You want to run it on the Mac or you want to run it on a PC or on all these different OS and different hardware. That's the best way why you would want to convert it to Onyx. And of course, if you have models that are created from different frameworks, especially if you have something that's written in the PyTorch, and then another team wrote it in Keras and those kind of all these different frameworks, and now you want to incorporate it to your application, that's when you're going to use these Onyx models. And of course, this is something new, which is called transformer models, that you can also use it for training at the edge or within your application. If you want to improve the model and add some training inside your application, that might be a good way to go. You might want to use Onyx then. So Onyx Runtime allows us to be able to have, add inferencing to your application, right? In this case, you go to onyxruntime.ai, and you'll see this page where it says, okay, do you want to run it on Windows? Do you want to run it on Linux or Mac? Like in this case, we're going to run it on Windows. And we know we have a C# application, so we'll select C# here. And then with the architecture, we want to run it as 64-bit, and we want to use DirectML. When you select these, it would tell you, hey, there's a NuGet package that you can install. and it would kind of point you at the right direction. So there's a lot of different combination where you can run this Onyx runtime. You can actually even run it on the browser itself. So it's well worth learning more about Onyx if you're interested into integrating machine learning into your application. All right, so moving along, we'll talk a little bit more about this ML.net. What is ML.net? It is machine learning to .NET application. It can run online or offline, meaning you can run it in the cloud or you can run it as part of your application. The goal is to have automatic predictions, adding automatic predictions to your application, generate a machine learning model. So ML.net allows you to be able to generate a model. What is a model? Of course, we did talk about that. It's to transform input data into prediction. You can also use ML.net to import a pre-trained TensorFlow model or an Onyx model and integrate it to your application. It does support Windows and Linux and Mac OS. There's this ML.net model builder that you can use. It is a simple UI tool in Visual Studio. It's specifically made to build, train, and ship machine learning model to train. So it's not just train it locally. You can also train it in the cloud. You can use it to train models from your computer to the cloud to send it to Azure. Of course, it's connected to Azure. And the main goal of the ML.net model builder is to generate a custom machine learning model. So what is this model builder? What can it do? It can do data classification. It can do value prediction, image classification, recommendation, and then object detection. Today, I will show you image classification. But notice how in this model builder, you can actually do data classification locally in your machine. So if you want to try out, data classification, you will go through this step-by-step process, run it locally on your machine. Now you have a model. But for the image classification one, notice how you can send it to the cloud, to Azure GPU. So there's Azure Machine Learning that has a GPU processes on it. So if you want to train a model that is using the GPU in the cloud, you can pass through there. I will show you how this one kind of walk you through what that one looks like. You can also use the local GPU. So this one uses specifically NVIDIA. So you might have to install DirectX, not DirectX, but you might have to install some software in order to run it locally into your, if you want to use local GPU to do this. Okay. So some guide into using model builder. If your data set is about 0 to 10 megabytes, you can train it for 10 seconds. It's most likely will find a solution for you. It's actually in the background, it's using AutoML, which tries out all these different machine learning algorithms for you and picks out the best. So it's more of a model fine tuning. It tries to figure out different combinations of parameters for those models, and then it would give you the result. So if your data is about 500 to 1 gigabytes of data, most likely it'll take about an hour to train, not just locally, also it also depends, how fast is your CPU, how fast is your machine, how many columns you're talking about, what algorithm it's using, those kind of things. So the main goal is you import the data. Data can be coming from a SQL server, data coming from a CSV file. and then you use it to train the model. And then after you train the model, you evaluate how good it is, and then you generate a code to be able to incorporate it to your application. All right, I'll spend a lot of time on the model builder, and that's what I wanted to showcase to you today. Okay, so what is this model builder? So I'm on Visual Studio. I have this project. Actually, at first, I created this as a console app. And to make sure I have this model builder, you're going to make sure that you have it in your application or in your extension. So there's an extension called ml.net Model Builder 2022. There's also 2019 if you're still using 2019 version, but make sure you have the extension. I also installed the Model Builder GPU support, so I have both. I think by default, when I installed my Visual Studio 2022, it had this Model Builder already installed, so you might want to check that out. And what that allows you to do is when you go to, let's say, this console app and you hit add, you would have this machine learning model that is here. So I already added this, and it would look something like that. And it would go through each one of these different tabs. You go through each one of these tabs, and you go to this scenario. And like in this case, we're doing image classification, but you can use it for data classification, value prediction. You can use it for recommendation. I can't say that word. Object detection. You can do forecasting. There's also anomaly detection and clustering. But today we'll focus on this image classification. So you can actually train it in Azure or locally. Then you go next step. This case, if you want to train it local GPU, it's fine. You can do that. Local GPU, it would give you, it would check if it's compatible or not. So like in this case, it knows my graphics card is NVIDIA Quadro, which is I'm using a laptop. It's slower, but you have to install these different things. I know it's kind of harder to read because I already have installed, but you need to have CUDA installed. There's a lot of steps involved in order to do this, which is not too bad. I mean, just go through each one. And then if you want to do it in the cloud, you can do this and set up the workspace. You specify which one are you working with. Of course, give me this error. I already did this, already. I don't know why it's giving me this error, but I think it has something to do with the policy. But you can set up the workspace. It would use Azure Machine Learning to send it to the cloud. To do this, you might need to, in my case, I did have to upgrade on Azure Machine Learning. I have to upgrade the number of CPUs that I can run in order to get the correct compute in order to run it in the cloud. And it did took about an hour or so in order to do this for me, to run it in the cloud. And what it would do is it would, you have these files locally in your machine. It would upload it to Azure Machine Learning. It would do its training, and once it's done, it would give you the result. So moving along, on the data side, what I have these list of pictures. In this case, daisy, dandelion, roses, sunflowers, tulips. So it is on a certain folder. It looks something like this. So each one of these on the folder. Here's my, okay, it for some reason it doesn't show the files, but the files are there. It looks something like this. You have your folder, then what is the label name, and then the image samples. So those are the images that is on that folder. And once you're done, you hit train. In this case, like I said, I did use Azure in order to do this. I sent it to the cloud. It took about an hour or so, or more than an hour or so, in order to do this. it built the model. After it's done, it would it would connect back to this model builder, and then now I can evaluate whatever that model it returned. Like in this case, it returned this DNN plus SEREX ResNetX. I don't really know how that one works, but it did figure out that's the best model, custom model or model base that it would use, and it generates a custom model for me. I can try images. Like in this case, I want to try this sample image, and then it would give me the result. Hey, that is a sunflower. Any questions so far? Is this making sense in what I'm kind of talking about? This model builder, how it kind of flows through one step by step. It's kind of like a wizard, right? It flows you step by step instruction on how you would build your own custom model, and you can actually evaluate at the end to make sure it is looking good. It was looking, that it can do some prediction, and then after that you have this consume, and this consume is where you can identify. It actually kind of gives you a code snippet here how you would use it. Like in this case, you have this JPEG file, and you would call this, if you would pass this into this model input class, you pass it the image, and then you could say predict. And it has these model templates too, where you have you can add it as a console app or a web API application. In this case, let's look at this console app that it did. So notice that it is actually using Microsoft.ml, which is the ML.NET, Microsoft.ml.image analytics, Onyx Runtime, and Onyx Transformer as the NuGet packages. And once you kind of click this add solution, it would generate these. It actually makes, since I train it on the cloud, it actually generates this Onyx model for me automatically with the, with whatever this base model where it came from, and also how to consume it. Notice how there's this consumption.cs. This consumption.cs kind of have these input class, what does your model needs, and then also the output class and what your output would be. And also it has these labels already integrated in. So when you start training them, it already integrated what are the available labels that it would return, and it would give you the prediction and how to predict it properly and give you the proper prediction. So in this case, if we go to the program.cs, how you would use it, it's a console app, uses system.drawing, use image.from file, you specify the JPEG that you wanted to load to this image variable. You would integrate it to this model input and to this image source, and it's expecting a bitmap. It knows, the interesting part of it is it knows how to convert the image into the right size of what your model needs. And once you do that, you can just say ml1.predict. You specify your input, your model input, and it will give you the result. And then based from that, you can figure out the prediction and then the score. So let's try to run this. See, it goes to my other window. And there you go. It loaded the image. It predicted that that image is a daisy, and with that score. So what does this score mean, right? I mean, there's numbers here, and of course there's that e of something. So of course, there's a exponent. That means this is a smaller number. This is a smaller number. It's a smaller number as compared to this. So that tells me that label score of Daisy is the highest with that 99% score. How did I know what these values where does it represent, right? So if I go back to these consumption, right? Notice how the order of the labels are. So Daisy was first, or second is dandelion, roses. So each one of those values that I showed correspond to the prediction for each one of these. So it find out on the picture it is 99% Daisy. That's the reason why it picked Daisy as the highest. Cool. Any questions so far? I know I did talk a lot, kind of not an easy topic. If you're new to machine learning, there's a lot of ramp up. Are there any questions? Okay. All right. So what is this Onyx model? I wanted to kind of, since we have a few minutes here, I wanted to showcase what does this Onyx model looks like, if you're curious. Okay. Trying to open this file in Explorer. So I have this application. See if it'll open up. Okay, doesn't look like it's taking a while to open up that file. I'm not sure why. But I know I can open up with Netron. So Netron is this app right here that you can install locally in your machine. And this Netron app, and what it does is actually can look at an Onyx model, and it would try to visualize it. Okay, it does look like it's taken longer than usual. Try to close that again. Try it again, just to, okay. Open with Netron. If not, that's okay. Okay. Yep, doesn't look like it's opening right now, or maybe it's taking its time. Okay, we'll move further.
I can't reach the internet right now. Check your modem or router connection and try again.
Okay. All right. So we did talk about the model builder. We did do a demo, a little bit of what you can use it for, what are different steps. So just to summarize, okay, now it showed up, the Netron. So this is what Onyx file looks like. It is, this is how you can kind of visualize. It goes through from this input. Think about this image. Actually, the image that it needs have to be a certain size. Think about this 224 by 224 by 3. So what this tells me for this model, it needs 224 pixels by 224 pixels of that image has to be resized. 3, that means it's red, green, and blue. So those are the input that it needs. On the output side, notice that it is a list of float 32 or tensor of float 32, which has 5 items on it. And that corresponds to our labels, right? So it would go through, it would process from here, it would have these operations to do its inferencing, and at the end, it will figure out the output. So these are the different machine learning operations that it's doing as it flows through and predict. All right. So in summary, I just wanted to, we did talk about what is Onyx Runtime. Oh, we did talk about what is machine learning. Machine learning, it comprises of two phases. You have the training side, where you're creating a machine learning model, and then the inferencing side, where you're using the machine learning model in order to do your prediction. What is Windows machine learning? It's a way to implement machine learning specifically for any Windows application. So it could be UWP, it could be any of the, of course, Windows Forms. You can use Windows machine learning and incorporate it on your Windows Forms application. What is Open Neural Network Exchange, which is sometimes called Onyx? It is a model file or a format, just like a PDF, to do an interchange or exchange of this model file. What is Onyx Runtime? It's an API to use Onyx Model into your application. What is this community toolkit? And I did talk about this community toolkit, intelligent API. These are NuGet packages to add computer vision models into your Windows application. And I did kind of showcase a little bit of how you would easily add these computer vision model into your UWP application. And then what is ML.net and what is ML.net Model Builder? It generates a custom machine learning model specifically inside Visual Studio. It showed you step-by-step instruction or a wizard type where you're trying to identify what is the what classification. Like in this case, we did choose image classification. Where are we going to train it? Which images are we going to train it with? We specify, and then we send it to the cloud to be trained. It spit out the results, gave us the best model that fits to our data set. We evaluated how good it is, and then we created a sample project incorporated into our application. And then then we tried to run the model that it did generate, passing it the correct input and parameters, and then it gave us the prediction. All right. These is the link to the GitHub page. I will make it public after this presentation, so that if you're interested in trying out all the different demos, feel free. All the 3 applications that I did showcase today is there. Feel free to try it out and kind of learn from it to kind of understand what this ML.net and what is these different technologies that I showcased today. If you're interested in learning more about me, my name is Ron Dagdag. I'm a lead software engineer at Spacey. I'm a 5th-year Microsoft MVP awardee. Best place to contact me is at Ron Dagdag on Twitter. Dagdag.net is where I blog some of my information. LinkedIn is also the best place to contact me. And I appreciate you geeking out with me about Windows keys, ML.net, Windows AI, and all things Windows stuff. I appreciate your time. I am open. I know there's a lot of things that I did cover today. I understand it's not easy to grasp all that. This would be the best time. If you have any questions, feel free to ask and feel free to comment out. Cool. All right. is this helpful? This is my first time to present this topic. I know it's a lot of different things that's going along. I appreciate you giving me some feedback on it because I enjoyed the topic, especially the Windows keys. All right. Thank you. Very good. So, yeah, I did definitely using the Windows screenshot key. That is very helpful, Slick. That is a very useful key. Yeah, I didn't want to delve down deeper into like what is the machine learning, all these different algorithms and all that. I want to showcase the high level things that you can do now, especially if you're a Visual Studio, or if you're using Visual Studio, if you're using machine learning and you're a .NET developer. These are different things that you can do. Feel free to try it out and send me send me a message on Twitter or send me a message on LinkedIn, especially if you learn something new about this and if you're able to integrate it to your application. I would like to hear, because it is this. I think this is something that we can start. So I will right now. The repository is private. After this presentation, I will make it public, and so that the link is actually on the chat if you want to try this out. And also it has the PDF version of my presentation today. Cool. Are there any questions out there? Any other questions? Feel free to unmute if you want. Feel free to put them in the chat. We have 5 minutes to talk about it. Or if there's something unclear or something that you wanted to learn more about, this would be the best time to ask. Cool.
Hi, I was wondering, what do you need as far as a Azure subscription mod, and how much do you have to pay to get these tools? Or are they
so you need
free?
Yeah, from what I understand, you can try it locally. That's the cool thing about this. If you can run it locally and if it's good enough, why do you have to send it to the cloud, right? If I have a performant laptop and I have Visual Studio, you can do this. You can try out all the different, algorithms, the classification, all the different algorithms that is available there. You can try it out. I would try it out first locally on my machine, get it running. But on the cloud side, on Azure, you need Azure Machine Learning to do this. And the cool thing is, which I found out, is that when you run it, it only charges you while it's training. It's not like, you have a VM out there that's constantly running and waiting for you to send. But if you have Azure Machine Learning and if you created the compute needed to do this, and there's steps involved in order to do that, you can it after your training is done, it deallocates itself, and then of course whenever you want to retrain again, it would send it, it would spin up compute, because it is in a cluster. So in the compute cluster, it would spin up the node. And once the node is ready, it would start processing your data sets again. And then it would generate a model and then would return it back to Visual Studio. So that's what's cool about it. I didn't get charged as much. And I think the cheapest one that I saw is like maybe is it almost like $1 an hour? And it cost me about $1 to train this. $1, maybe $2 to train what I showed you today. So it's not too bad, but of course, I actually train it locally on my machine, and actually it takes like less than 5 minutes or 10 minutes to run. It takes longer in the cloud. It takes because of the spin up, all these other things that it's doing. Running it locally, if you can get it running locally, it makes sense. I did not use the the dollar. I did not use the CPU. I didn't try it with CPU because it was taking longer to run it under CPU. But the GPU one locally, I think it was quick, and the Windows one, I definitely would. You know, if you want it also repeatable, if you want to keep track of all these runs and all these models that you generate later on, I would use Azure Machine Learning for that. It has a way you can store and go back to all these runs, meaning every time you submit a run, it keeps record of each what's the output, what's the log, what failed. It makes it easier. Just maybe since I have 1 minute left. I wanted to show you what it looks like in the cloud side. There's different what you call these, what the logs would look like, but I don't have enough time to go there. But the GPU cost is not bad because it only wakes up when you need it. Cool. Well, thanks for hopefully that answers your question. Thank you for that. Anything else? So you might think that machine learning is magical and with unicorns and what is it on Windows? You have one of those unicorns and the cat. I believe Visual Studio is helping us kind of make it easier for us developers. Of course, there's always a need for a data scientist. There's always a need for someone that would analyze, but they can use the model that we start with, right, using Visual Studio Model Builder, and then base it from that. The cool thing is it allows you to it also tells you what algorithm that it did pick. So if you give that to a data scientist, they can start from there. Does that make sense? So even though you train it, maybe it was good enough. Let's try it with what's good enough. And if you want to improve, and if there's something that a data scientist can do to improve it, then you hand them, okay, model builder, let's start with this one as a baseline, and then get an improvement based from there. Cool. I'm running out of time. I appreciate you spending mornings with me. I'll talk to you guys later. Thank you very much.